I'm here to teach you about how to convert between different metric prefixes using dimensional analysis. In chemistry, we work with a lot of different units, and we have to represent their different sizes using metric prefixes. An example of this would be we would use liters when we're working with large volumes. We'd be working with milliliters when we're dealing with small volumes. Obviously, a liter, 1 liter, is greater in size than 1 milliliter, and hence how we have to use these metric prefixes below. And the ones that we're going to be working with in this class are primarily kilo, centi, milli, and occasionally nano. Alright, now I'm going to show you how to do a problem where you have to use these different conversion factors. Say I'm given information on a kilometer, and I want to convert it into a meter. So I'm going to be using this conversion factor right here. And I'm going to write that conversion factor down on this paper here, and it's that 1,000 base units are equal to 1 kilo base unit. Alright, let's explain what this conversion factor is and how we can use it more effectively. Say I'm given a distance of 5 kilometers, and I want to know how many meters that is. Alright, first we have to know that this conversion factor right here can be simplified into the following conversion factor. It can be simplified by writing 1,000, and the base unit we're working with in this case is we're dealing with meters before and after this conversion. You'll know the base unit because it stays the same before and after your conversion. This is what we typically refer to as our known information, and this is what we refer to as our unknown information. If the known matches the unknown with 1 unit, that's your base unit. So 1,000 base units are equal to 1 kilo base unit, and the base unit we're working with is, of course, meters. So the conversion factor I'm working with in this problem is that 1,000 meters are equal to 1 kilometer. So I write 5 kilometers times 1 fraction, because I'm only dealing with 1 conversion factor, are equal to, and then I write the unit that is unknown, which are the number of meters. Meters goes on top because that's what I'm going to. Kilometers goes on bottom because that's what I started with. I get the numbers from the conversion factor. 1,000 is next to m, so I write 1,000 next to m on top of my fraction. And then I write 1 next to the km, which are my kilometers. So it's 5 times 1,000 divided by 1, which is 5,000. My kilometers cancel out, and I've got my answer. Now, there are some problems where we have to deal with 2 conversions. I'll show you an example of this. Say I'm dealing with 7 kilograms, and I want to know how many milligrams that is. Well, to solve this problem, I again look at all the conversion factors we have for this class. So, I look, and I know that I'm dealing with kilo, and I'm also dealing with milli, because the problem's starting with kilograms and I'm going to milligrams. That means that I'm going to have to use 2 conversion factors. I'm circling the 2 conversion factors I'm going to have to use in this problem, and I'm going to copy them down in the problem. So I'm working with kilograms, so the conversion factor I know is that 1,000 base units, and my base unit in this problem is grams, are equal to 1 kilo base unit, and the base unit is again grams. So 1,000 grams equals 1 kilogram. The other conversion factor I need to know is that 1,000 milli base units, and the base unit I'm dealing with is grams, is equal to 1 base unit, which is a gram. So these are the 2 conversion factors that I'm going to have to use in this problem to convert kilograms into milligrams. So I know that I'm going to have to use 2 fractions. So I write out 7 kilograms times 2 fractions equals milligrams. Since I'm starting with kilograms, my first conversion factor, I put kilograms on bottom. Since I know I'm ending in milligrams, I put milligrams on top for my last fraction. So the first conversion factor I'm going to deal with is 1,000 grams is equal to 1 kilogram. So I'm going from grams to kilograms, or in this case kilograms to grams, so grams goes on top. Now I write the numbers down from the conversion factor, and then that fraction is set up. The next one is going between milligrams and grams. Milligrams is on top. I'm going to need to cancel out these grams, so I put grams on bottom. I have 1,000 next to milligrams, so I put 1,000 next to milligrams, and then I'm just going to put 1 next to grams. So kilograms cancel out, the grams cancel out, and I'm left with just milligrams. So it's 7 times 1,000 times 1,000, and then I have my answer. This is an example of how to do a conversion when you're dealing with 2 conversion factors using this method called dimensional analysis.